Alright, in this video here I'm going to look at one or two example problems involving angles of elevation or angles of depression. If you didn't watch the video I did on the definitions of angle of elevation, angle of depression, you should definitely check that one out. I explained what those two mean. I also went through one example on that video already. Here I'm just going to do one or two more examples just to give you some more ideas of how to solve these types of problems. Right, so we're 500 feet from the base of a building. The angle of elevation to the top of the building is 24 degrees. The angle of elevation to the top of a flagpole atop the building is 27 degrees. We want to find the height of the building and the length of the flagpole. Alright, so first thing when you're doing a problem like this, it's a really good idea to draw a picture of it. So we've got a building. We have a flagpole on top of the building. And we are, 500 feet from the base of the building is where we're doing these observations. So wherever we are 500 feet away, the angle of elevation to the top of the building is 24 degrees. Right, so remember, angle of elevation is from the horizontal up to whatever it is, the object that you're looking at. So from the horizontal up to the top of the building is an angle of 24 degrees. Right? The angle of elevation to the flagpole on top of the building is 27 degrees. So if I'm looking at the top of the flagpole that's on top of the building, that angle is going to be 27 degrees. Right, which makes sense, it's a little bit bigger because I have to look a little bit higher to see the top of the flagpole that's on top of the building. And we want to use that information to find the height of the building and the length of the flagpole. Awesome, sounds like a good time. Alright, so I want to find first the height of the building. Let me try to do that first. So I'll label that height of the building H. Right, and what I have here is a little right triangle. Well, I have a couple of right triangles, but I'm going to take the smaller one that's on the inside. Right, so what I have, if I'm just looking at the height of the building, which again I labeled H, we're assuming that the building is standing up straight, so it makes a right angle with the ground here. My angle of elevation to the top of that building is 24 degrees, and I'm standing 500 feet away. Right, so there's a right triangle that models what's going on here for the height of the building. All right, so again, forgetting the top of the flagpole for now, I'm just taking that smaller triangle that's in there. And now what I need to do is solve for H. So it goes down to the definitions of the trig functions for right triangles, right? And it comes back to SOHCAHTOA. And if you haven't seen the videos that I've done on the definitions of the trig functions in terms of right triangles or what SOHCAHTOA even means, you should watch those so you understand what's going on here, right? So SOHCAHTOA, so my angle here is the 24 degrees. What I'm trying to find, the height of the building is the opposite side from that angle, right? The hypotenuse would be over here. That would be like the line of sight distance between the observer and the top of the building. And that makes the adjacent side, this distance from the building, this 500 feet, right? So I'm looking for the opposite side. I know the adjacent side, so I need to pick the trig function, either sine, cosine, or tangent, the one that relates the opposite side with the adjacent side. So that's the tangent function, right? That TOA, T-O-A stands for tangent, equals the opposite over the adjacent. Right, so my tangent function, tangent of 24 degrees, is going to equal my opposite side, H, over my adjacent side, which is 500. Right, and then that's the equation that I can use to solve for H, the height of the building. Right, so it's all about being able to read the problem, draw a picture based on what you're reading, label everything, put all the numbers in the right spot on your picture, pull that right triangle out of the picture, and then identify which of the three trig functions, sine, cosine, or tangent, is going to work for what I have. And it's all about what side do I know and what side am I looking for. I know the adjacent, I'm looking for the opposite. I need the tangent function because that relates the opposite and the adjacent. Right? If I had the opposite and the hypotenuse, I would use the sine function. If I had the adjacent and the hypotenuse, I would use the cosine function. All right, but this one's going to be tangent. So let me get this out of the way here. All right, so tangent of 24 degrees equals H over 500. And then to solve for H, I would have to multiply that 500 to the other side. Right, so 500 times tangent of 24 degrees. And since the 24 degrees is not one of the angles that I know from the unit circle, that means I need to use my calculator to solve this. Double check that your calculator is in degree mode, which the third line down on my calculator, radian and degree, mine is in degree mode. So I'm all set to go. And I just type in 500 times tangent of 24. All right, so I do 500 times tangent 24. I hit enter, and I get 222 point something, 222.6. So the height of my building is approximately 222.6 feet. Right? It is feet. Yes, we were 500 feet from the building. Whatever length, whatever unit of measure they give you for the distance in the problem, you just use that same unit as you go through the problem. So if we're given feet, then our answers are also going to be in feet. All right. So the height of the building is 222.6 feet. All right. So there's the height of my building, and now I want to find the length of the flagpole that's on top of that building. All right. So I'm going to actually have to erase all the words up here, so I have enough room to actually solve this problem. All right, so to find the length of that flagpole, I'm going to have to create another right triangle, right? And here I'm going to go, this vertical side here. Let me call that K. So that's going to be from the ground up to the height of the flagpole, the top of the flagpole. I'll call that distance K. All right, you might say, well, what if I just work with this little triangle in here? The problem with that is that little triangle that's in between the top of the building and the top of the flagpole, that's not a right triangle, right? So there are ways you can work with a triangle like that to solve it. I haven't done any videos on that yet or talked about it yet. I will be doing that soon. But for what we know right now, we have to use just right triangles, which means I have to take the big triangle here, right, which is the 27-degree angle down here. Right, that's the line of sight to the top of the flagpole. The height of the top of the flagpole from the ground we're calling K, and we're still a distance of 500 feet from the base of the building, and we're still assuming that that building is standing up straight, so there's a right angle there. Right, so what I have here looks a lot like what I had over there, right? I just have a different angle because now I'm looking higher up, so I have a higher angle of elevation. And I have a K here instead of an H, right? The H represented the height of the building. The K represents the height of the top of that flagpole. So if I solve for K, I can find the height of the top of that flagpole. And then to see how long the flagpole is, I just do that distance minus the height of the building, and that'll tell me how tall the flagpole is just on its own, right? And to do this, I mean, it's going to be a lot like what we had before, right? My K that I'm looking for is the opposite side. The hypotenuse over here I don't really care about. The adjacent side is the 500 feet. So once again, just like over here, I'm using the tangent function. Like it's almost the same exact thing I did here, just a slightly different number for my angle. All right, so I do the tangent of 27 degrees is equal to K over 500. Once again, I multiply that 500 to the other side. So K is going to equal 500 times tangent of 27 degrees, just like down here, H was equal to 500 times the tangent of 24 degrees. So it's almost the same thing I just typed in. 500 times tangent 27 now. I almost looked at the wrong spot and typed the wrong number. That would have been dumb. 500 tangent 27, and I get 254. Let me turn it around so I can actually read it. 254.76. So let's call that 254.8 feet. Right, so my K is approximately 254.8 feet. Right, so that's not the answer to the question, though. Remember, the question asked, and I probably should not have erased it so you can actually read what it asked us, but the question asked us, what is the length of the flagpole, not how tall is the top of the flagpole from the ground. So the actual length of the flagpole itself would be K minus H. So if I do 254.8 minus 222.6, that's going to give me 32.2. Right, so the flagpole itself is about 32.2 feet tall. All right, so that's the height of the flagpole that's standing on top of that building. All right, so this was like a two-step problem. If I wanted to find out how tall that flagpole was. So first you have to find the height of the building using the tangent function. Then you have to find the height all the way to the top of the flagpole, and then subtract those to actually get the height of the length of the flagpole itself. All right, so that's another example of doing angle of elevation. Angle of depression, remember, is the same idea. It's just like if you're standing on a cliff or something and you're looking down at something else. Remember, the angle of depression is the one that's in relation to the horizontal line. Right, so if you ever see a word problem like that, that's what the angle of depression is referring to. All right, angle of elevation, angle of depression, always in terms of the horizontal, never in terms of the vertical. Right, it's the most common mistake people make with problems like this. All right, so those are our examples on angles of elevation and depression.